Okay, class, we're at weekly update 12. You just finished book 3.5, the first half of chapter 2. So some neat nonlinear space curves and some interesting things you were able to do with them. Okay, so a couple, let's start with the activities. So really nice job. I put quite a few in the samples and examples. Christy, Griffin, Patrick, Clarissa, Dana Mae, and Aaron, and all for different reasons usually. So that's why it's neat to just quickly scan through your classmates' work. Patrick and Clarissa had some really nice, they did the roller coaster with the charging cable and some really nice images, and then drawings on top of that talk about the secants and the tangent vectors and the non-differentiable points. So check their images out. And then Dana Mae had a nice plot on the, or nice ideas on the matching. And this is important for, most of you guys do a great job. In fact, I remember Liam and Will and Christy and maybe Keegan, really nice job on any of those matching where you're explaining sort of your thought process, like how you did a process of elimination to narrow it down. This one must be the helix, and this one's also a helix, but this one may be circular, this one's elliptical, and sort of walking through that. And you, it's interesting to see how many different approaches there are to that matching problem. But just a warning, there's still maybe a few of you, maybe to a handful, who aren't, you're just putting a letter and not showing anything about your thought process. And this is important for Chloe and I with the grading, that we need to know, because the answer's at the bottom, right? You could easily just be like, oh, E, B, C, but add a few comments, you know, what it was that clued you off that that was the one that you were choosing. And so, oh, I was getting back to it. So Dana Mae had a really nice job on one of those matchings. She actually was like figuring out where the points were on it by setting up the table. So you could do a table like T is this, so then X of T is that, Y of T is that, Z of T is that. And she put in a few points and then just sort of got an idea for the visual that way. And Erin had a nice one because she had some, she included in appending it with several CalcPlot 3D visualizations that helped her work through these activities. Okay, and then just to tighten something up on, this was the only place it seemed the activities were very straightforward. The only place where there was some, wasn't clear that all of you got this point, was on the space curve on your hand, on the heart line. So you extend the heart line and then maybe you had some ups and downs. And so in here, so that's a space curve. And the two questions at the bottom were about what happens when the derivative or parts of that derivative are zero. So r prime of t has an x prime, a y prime, and a z prime. And you're about to, in the next part, learn more about when all three of those are zero. So if there is no change in the x or the y or the z, what that means. And that has to do with something about the point being smooth or non-smooth. But this one was asking where just the z component. So there is no change in the height. There might be change in the x or y, but there's no change in the height. And it turns out that those are good places to look, just like in Calc 1 for local extrema. They're not necessarily local extrema, because remember in Calc 1 you could have that like x cubed function where right at 0 it's a critical point because there is no change in the height. For us, that's z now, but there it was just in the y. But that is it's an inflection point. It's a critical point that's not a local extrema. So that's possible. So the answers to those last ones are relating to if the third component in your derivative is 0, you could have a local max or a local min, not necessarily. Okay, then on the calculations, very nice job overall. It looked like, thank you to Eleanor, bonus point to you for noting. Many of you saw this, but you didn't say anything to me. So Eleanor had the guts to say, I think there's an error, and she's right. One of the curvature problems, I asked you to do, compute the curvature at the point 1, and the decimal that I have at the bottom is not correct, but many of you got that. In the samples and examples, I put work by Will, Christy, Patrick, Clarissa, Dana Mae, Aaron, and Grant. And just a few comments. It was neat to see also the merging of, some of you just love to calculate, human calculators, that's great. I'm thinking, I think like Allie and Kelly, I think are the ones that always just go straight down cranking away. But there was neat to see this time, many of you merged that with a tech tool. So like Grace and Kelly and Griffin would start some things by hand, then they'd say like, getting nasty, getting pretty messy, let's jump to the tech tool, or just using a tech tool to check how far you've gotten. And that's a nice skill to know when to use a tech tool and when not. And I remember actually a couple weeks ago having a correspondence with Griffin about, is this I think it was an integration problem, like, is this an integral that I can do? Is this am I just forgetting some integration rule from some obscure integration rule from years ago? And it turned out for that particular one, he was not. There is no rule for that. You're going to have to use a tech tool. They have to use a numerical integration. And that is a useful skill to know when you can do something by hand, when you should give it, when it's just futile, can't be done, when this isn't maybe worth your effort, or if you just like to, crank through that and see, can you get it by hand? I remember sitting in the library in college doing integration problems too. So Griffin's comment reminded me, I just went back to Mount St. Mary's in their library and sitting there, I used to sitting at the table and there was integration problems, and you knew, especially in that, different than maybe our books, you knew that because it was in that section, it had to be, okay, well, I had to use, maybe they were teaching us about trigonometric substitution or integration by parts. So there was it was almost like it was a puzzle to me. Like, okay, I have to be able to figure out how to massage this function to fit one of those few rules. Or when you got to the chapter review, there were more, but still it had to be a way to do it, because if it was in that textbook, it had to be that you could do it by hand. But you don't have the luxury of that here with these journals, because I'm mixing a lot of computer-based and hand tools by hand. Okay. Next, discussions. These were really fascinating. Thanks to the folks who did it. Many of you seem to be skipping that in these later weeks. So please go back and I hate to have zeros for people. Those are the things that really do pull you down. Like, I thought I should have had a B+. Why am I at a B-? So, but this week the discussion was, what's it like to do math? And so they're at this high level that y'all are doing it. Many people don't get to this level of mathematics or don't have any interest, or don't have didn't build up this way. And it talks about Andrew Wild's answer, maybe Terrence Town, and there's an article that this was asked on like a forum, and some, I think it was a PhD in math answered, and just talked about how you can sort of compress so many ideas quickly. And so I want to talk through a few of these, because I really enjoyed reading these. So Griffin talked about how he can make so many pull connections from different things. Like, maybe it's asking you to do a volume of this crazy shape, but that's sort of got some spherical components, and he can get a decent approximation. Oh, and that reminded me of Lothariel's answer was, he had something to do with how he does the problem solving. He's really tries to take an unconventional approach, and that's cool to see. And you can see it in your guys' group work too. How he'll dissect a problem and kind of start with what he knows and see how far that can take him, or can he just get an approximate answer using something and then refine that. So, and then Griffin talked about the ability to sort of extend those ideas elsewhere. And that's really, again, what I'm hoping, that you guys can make these connections and make extensions. And that's when you're really inventing things yourself. You're not, this is cool to see this progression during the semester. That math is not just memorizing and rote learning. And let's see, one that actually made me literally LOL, laugh out loud, was Patrick. He was talking about he's taking a philosophy class, so he's sort of relating some of this to philosophy, but he talked about the misconception that frustrates him, that a lot of people think higher math is impractical. You go higher and higher, and it gets less and less useful. And he talked about how many times people say, well, trig is useless. He said if he had $1 for every time he heard that, every time someone told him trig was useless, he could afford to buy something to hit him with. Literally, as I was reading, made me chuckle. And Grant was mentioning again that he's enjoyed learning higher math, and maybe never thought of himself doing it and really And I just want to say, yes, Grant, you absolutely should go farther in math. You should continue rocking this class. I think you really enjoy. If you haven't taken linear algebra yet, and all of you take linear algebra. It's a co-requisite, or you can do it afterwards, 203. And if you get a chance to take it with Kate and Owens, you'll have a good time. The experience can be very different depending on the instructor, but it can be very visual, linear algebra as well. Dana May, I appreciated your discussion too. She talked about how at this level, it's been so much more fun for her because they are like puzzles or games, like trying to do a problem is just like a puzzle or game. And that's a great way to think about math. And that's how I've done, like I was just telling you about the integrals. It had to be that I could do those, just figuring out that puzzle, even though it was a tedious, calculation problem. But she also talked about how you have to, like, reminds me of Griffin's answer to, you're pulling connections together, like from many different places. And that there's a lot of ways to solve a problem. In fact, many of you mentioned that. I love that and enjoy that that's the new take on how you're doing math, that there's so many different ways to solve it. Savannah said it can be really frustrating how prior and lower math tends to be taught that there's just one way to solve this, one answer, one method, and do it that way. And there doesn't make room for creativity. So this new approach where there's multiple ways, she talked about, it's made her rethink about to do problem solving. There's actually a strategy, and you have to strategize. I really like that word, to like approach a problem with a strategy. Cameron talked also about building connections with previous things, and how, like, for instance, in this particular module, curvature is really just connected to something else, or tangents and derivatives. Those are the same derivatives you were doing before in Calc 1, and that same idea of secants converging to a tangent. Well, it's not lines this time, we're talking about vectors and along space curves, but then it's easy because you're just building on things that you already know. It's like that. I don't think this article talked about it, but I know we have a couple math ed folks and future teachers. The idea, once you are learning more and more math, there's a term called procept, and it's the compression of a process and a concept. Like in the beginning, when you first learned subtraction, you probably learned it as a process, taking things away. And as you get further along, so originally you're taking this very rote sort of process way of learning that, but later, years later, you might be like, oh, and when you're learning about negative numbers or something, that things are just being extracted out or pulled away, all these different ways of thinking about subtraction, and they become the process and the concept, which had been previously separate, are now a procept, which is a quick compression. And this reminded me of several Griffin's comments that, like, yeah, I mean, something that took layers and layers before, and just so much more material and learning is now just like, oh, it's just that, like it's simple. In fact, that now reminds me of when I was in graduate school, actually in undergrad, I took a class in econometrics, really cool. It was an application of, well, it turned to be something called least squares, which maybe at the end of linear algebra you might learn. In a stats class you might learn it, but it's called ordinary least squares. And I've taken this and ended up doing my undergraduate thesis related to enrollment forecasting at colleges using econometric methods. And then when I was in graduate school, I was like, oh, I really like that undergrad. Oh, here's a class, I'll take one. And there was like a econometrics 1 and econometrics 2 at the graduate level. And so I went over there and took those classes. I remember the books, and they were like this thick, and went through, and you learned all these things, like, okay, there's a chapter on what multicollinearity means. There's a chapter about rank independence, and entire chapters, and telling it from an econ, a lot of data and stats perspective. And then I took a graduate class in advanced linear algebra or matrix theory with my mentor, another book this thick. But in that thick book, there was like 2 pages that explained what ordinary least squares, which I had in my head thought of as an entire another book, a couple other classes, that once you knew the math, I could compress that entire book into these 2 pages. In fact, I could do even better. Oh, that's just a matrix. I'm just getting and these are things, if you're in 203, remember, if you're going to take 203, you'll see these soon. I got this matrix, and I could just take the rank of this matrix. Oh, and if it's this column is a linear combination of those columns, and that's really what that whole chapter of multicollinearity was about. So it was just really neat to be able to take with the structure and the vocabulary and all the things I knew from that math class and just compress all that ordinary least square stuff into, oh, that's just an idea. And then I'm going to solve that with a linear squares system, A transpose A, X equals A transpose B. So neat to see in many of your comments that this idea that compression and how connecting ideas, extending, taking something you know and trying to extend and create something new. And then this approach of like math is really just creative problem solving, many methods to solve something. Okay, let's see, a few of the thank you for all the folks that when you submit something, if you had an issue or something was late, you want to let me know. Thank you for letting me know that. I understand things come up, and it's just nice to give me those updates. And also, anytime you want to do office hours, I think a few of you have mentioned something like, kind of struggled with this homework, let's meet up. But many times by later in the week, if I've tried to get back up with you, you're like, oh, I got it, which is awesome when you get it on yourself, get it figured out yourself. But at any point, if you want to do an office hour, we've been a lot of email conversations back and forth, but we can also do Zooms, set up an appointment. Of course, if that's tougher of setting up appointments, remember there's the math lab, it's a lot more flexible. You can do those in person or virtually. With me and Chloe, Zooms anytime you guys want. So let us know if that's a need. But it looked like you did a great job this week. If there's ever anything you want to just tie up loose ends or be sure about something, let's set it up. Okay, and last thing, you've got some challenges this week. I think you're gonna have a really good time. There's 4 choices at the end of this chapter, and they're just really fun. I'm excited to see which ones you choose and how y'all attack them. I think you'll have a good time with the upgrades too. So enjoy this week, the second half of chapter 2.